All right, welcome. In this video, we're going to be talking about solving absolute value inequality. But before we solve any of these inequalities, we need to go back and talk about the equations that we solved last time. Okay, so what values of x make absolute value of x equal to 10? Okay, that's, lost track of part of my question. Okay, that's either when x is equal to 10, not 0, x is equal to 10, or x is equal to negative 10. All right. So if they asked us where the absolute value of x was less than 10, well, I can tell you it's definitely not going to be at 10 or negative 10, right? Because that would be when the absolute value equals 10. Let's bring in a number line. Okay, so if 10 is right here, and negative 10 is over here, and 0 is in the middle. Okay, well, I know that the absolute value of 0 is going to be less than 10. Okay, so that's going to be a solution to that inequality. But anything between 0 and, say, anything less than 10, between 0 and 10, we're going to have more solutions, right? Because the absolute value of 5 is less than 6 is less than 10. But if then we think about all the way over to negative 10, we're going to have some solutions over there too. And, right, it goes all the way up, almost all the way to 10, and almost all the way back to negative 10. But we're not so good at drawing, almost all the way to things like that. So we just would draw like an open circle. That's not the best ones I've ever drawn, but the values of x that make the absolute value of x less than 10 would be negative 10 to 10. Okay? If we wanted to write that as an interval, we could say negative 10, comma, positive 10, both with parentheses because we're not including either endpoint. Now, if we wanted to talk about values of x that make the absolute value of x greater than 10, we're probably going to need another number line. Okay, I feel like I was a little smarter there, drew my circles a little bit bigger. But the values of x that make absolute value of x greater than 10, well, that would be obviously values greater than 10, right? Because the absolute value of 100 is definitely bigger than 10. But also negative numbers that are big negative numbers, right? If a number is more negative than negative 10, then we would see its absolute value go back greater than 10. But again, negative 10 and 10, those are not values that are making that inequality true, because that would be where it would be equal to 10, right, the absolute value. Okay, now I'm going to need to shrink these up because I got one more thing that I need to ask you about, and that would be, what if we needed to make the absolute value of x less than negative 10, right? We've been only talking about positive 10. But if you think about it, our only options for an absolute value, the outcome, is you take the absolute value of 0 and you get 0, or you take the absolute value of anything else and you get a positive number. Okay, we never take the absolute value of something and get a negative number, so we can never take the absolute value of something and have it be less than negative 10. So no values of x is probably what I'd say here. Okay. And basically these situations here are what are going to we're going to keep coming back to time and again when we're solving these inequalities. All right, so once again, kind of like last time, we're going to give you a set of steps to help you solve some absolute value inequalities. And the first step is always going to be isolate the absolute value, right? Get it down to absolute value inequality number. And so I'm going to show you that in an example on the right, and I'll work that in black. So over here, I'm going to isolate the absolute value first by getting rid of this 2 here. So I'm going to subtract 2 from both sides. And I'll have 1/3 of the absolute value of x plus 1 greater than 4 minus 2 is 2. And then I need to get rid of that 1/3 because I'm trying to get just absolute value inequality number. So I'm going to multiply both sides of the inequality by 3. So absolute value of x plus 1 greater than 6. Okay, that's step 1. Okay, we are complete. Okay, now we're going to think about where absolute value is greater than or less than whatever number we're dealing with. So what I like to do, I'm going to try to do this in gray off to the side, or if I'm working in color. And so I would say, all right, think about where is the absolute value of a number greater than 6? And based on what I showed you before, it's always going to be either like one interval, or it's going to be like kind of 2 exterior intervals. And at least at this point, provided that we have absolute value inequality positive number. Now, there's some other fringe cases that I'll tell you about towards the end of this video, but for now I'm thinking, okay, where is the absolute value of a number bigger than 6, where x is bigger than 6 that way, or more negative than negative 6 that way. Okay, so over here I would say, all right, the absolute value of a number is greater than 6. Well, that number could be out here, or it could be more negative than negative 6. And either way, okay, I mean, that number, that's just that's just standing in for x plus 1. So I say that either x plus 1 is greater than positive 6, that's that, little gray arrow on the right, or x plus 1 is less than negative 6. That's that gray arrow on the left. And then I just solve these inequalities separately. Okay, this was step 2 right here that I did in gray and then black. So I'd say 2. And then I'm just going to start solving at these inequalities, and might drop it down a little bit to give some separation here. But if I subtract 1 from both sides, I get x is greater than 5. And if I subtract 1 from both sides of the next inequality, x less than negative 7. Okay? And we can put a little or there, or you can put a comma. In my class, it doesn't really matter. This is not an abstract algebra class, right? This is algebra 2. So we're not getting into the set theory. We don't really care so much about that. You really, as long as you're giving me some sort of representation of the solution area, then we're going to be happy. Okay, but if we needed to write these as an interval, we would say, all right, x is less than negative 7. That's negative infinity up until negative 7. Okay, parentheses around the negative 7 because it's a strict inequality. Parentheses around infinity because always parentheses around inequality. Or we can write a u. It means union. That means or, kind of in set language. And then 5 to infinity, well, I'll just write 5 to infinity. That's x is greater than 5. Okay? And that's how we are going to solve absolute value inequalities. So let's do some more. All right, so now we're going to just work a couple of examples. Yeah, and I think in class I worked the one and I had the kids in class work the other one on their own while I walked around. But I think I'm going to show you both of these because that negative 5y, it can cause a little bit of concern, when people are new to doing this. And if you're new to doing this, I don't want you to be concerned. I just want you to be confident that you can do this, right? Because I think we can all do this. So we're going to, on the left, I'm going to work this one first, and I'm going to start by adding 7 to both sides. So negative 2 plus 7 would be like 7 minus 2, that's 5. And then I get the absolute value of 3x plus 2 over here. And there I've got it. I've isolated the absolute value. I have absolute value inequality number. And so I need to just think, okay, where is the absolute value of a number less than or equal to 5? Well, I know where the absolute value of a number is equal to 5. We kind of studied that at length last time. Negative 5 and 5. And the absolute value would be less kind of in the middle. So like near where x is equal to 0, right? Because the absolute value of 0 is less than 5. Okay. So now if the absolute value of a number is less than or equal to 5, we know that means that the number has to be between negative 5 and 5, possibly including. And so I know that means in this case I need 3x plus 2 to be between negative 5 and 5. Okay. And then I'm going to subtract 2 from both sides of both inequalities. And so I'll have negative 7 less than or equal to 3x is less than or equal to 3. And then I can divide all 3 sides of this inequality by 3. And I would get x is between negative 7/3 and positive 1. Okay. And if I needed to write this as an interval, because I don't know, maybe I'm working a problem that says give your answer in interval notation, or I am solving a multiple choice problem and all the answer choices are in intervals, I'd say, okay, that's negative 7/3 up to 1, including both of them. You can show that with a square bracket. Now I'm going to work this one on the right as well because it's got a negative attached to the y. Okay, and it actually isn't going to make any difference just as long as we remember to reverse the direction of the inequality when we divide both sides by a negative number. We should be good. Okay, so I'm going to start by subtracting 3 from both sides. So the absolute value of 2 minus 5y is less than 7. Okay, I've got it down to absolute value inequality numbers, so I'm ready to just think about where is absolute value less than 7. Okay, well, I think that's going to be between -7 and +7. Okay. And, okay, so if the absolute value, I didn't write that in, the absolute value of a number is less than 7. Okay, well, number was just standing in for 2 minus 5y, so I've got 2 minus 5y needing to be in there between -7 and 7. And so I'm going to say that's between -7 and +7. And let's see, and I'm just going to start solving at y. So I'm going to subtract 2 from all three sides. So -9 less than -5y less than 5. And you might be concerned, like, is this going to, you know, like, what's going to happen here when I divide by -5? Doesn't that reverse the direction of the inequalities? It does. Okay, so I'm going to divide everything by -5. So -9 divided by 5 is positive. -9 divided by -5 is positive 9/5. Not sure if I said that right, but greater than y, which is greater than 5 divided by -5 is -1. Okay, now this isn't exactly how we would usually write, you know, a one interval using, you know, nested inequalities. What we would usually write is, you know, with the lesser number on the left. But see, this is the same inequality, right? I've got the y is greater than -1 while still less than 9/5, and it worked out. Okay, so if we wanted to write this as an interval, we would say -1 up to 9/5. And that would be good for us. All right, now here we've got a couple of more examples. And so I'm going to go over here and I'm going to say, all right, well, first job, isolate the absolute value. So subtract 1. Divide both sides by 2. Dividing by a positive number is not going to change the direction of the inequality, even if the other side is negative, right? And then I've got it down to equality numbers, so I need to think about numbers, and, you know, I'm over here. As I'm making my number line, I'm thinking about, wait a second, when can an absolute value of a number be a negative? Never, right? Yeah, because, you know, absolute value of 7x plus 2 can only either be 0 or positive. It can't be negative at all, and it definitely can't be less than -2. Okay, so absolute value of a number is less than -2? Never. So that's it, no solution. Okay. And then this one on the right, I'm going to say, all right, isolate the absolute value, so I get the negative absolute value of x plus 2 is less than 9 minus 5 is 4. Okay. Then I'm going to divide both sides by -1 to get just the absolute value on one side of the inequality. And that will reverse the direction. And that's greater than -4. And now I'm going to think about this in terms of just numbers on the number line. When is the absolute value of a number greater than -4? And it feels like pretty much always, right? Think about your options for taking the absolute value of x plus 2, regardless of what x is. You take the absolute value of a number, it's going to be 0 or it's going to be positive. Both of those outcomes are greater than -4, so I say always. And so my solution is all real numbers. Because really, any number you can think of, you can plug in for x in the original equation or the original inequality, and that inequality will be true. Okay? So the kind of the message here is that if you whittle it down to absolute value inequality number, and that number is negative, you need to stop and think twice. Okay. If that number is negative or 0, you're going to need to really be careful thinking through this. And if it's properly negative, then it's either going to be no solution or all real numbers. But you just got to think about it. All right, now I got 2 more special cases for you to think about. And so we're going to start at the top, kind of where like the absolute value of a number is positive, or the absolute value of a number is less than or equal to 0, and then we'll actually apply it with a inequality down below. So the first one, okay, absolute value of u is greater than 0. That's always, right? Except you remember, we can take the absolute value of 0 and get 0. So this is always, except for when we're taking the absolute value of 0. So when u is equal to 0. Okay? And we can write this by saying u is not equal to 0. Okay? And then if we were going to solve one that was like this, we could say, all right, I might, you could distribute the 2 if you wanted, but you're eventually going to have to divide by 2, so I'm not going to do that. I'm just going to divide both sides by 2 right now. So I'll have 3 plus the absolute value of x minus 1 is greater than 6 divided by 2 is 3. And then I subtract 3 from both sides and say absolute value of x minus 1 is greater than 0. And then I've got it down, so I need to think about numbers, right? I need to think, where's the absolute value of number greater than 0? It's like pretty much always everything except for x equals 0. Okay, so the absolute value of a number is greater than 0 when number is not equal to 0. Okay. And that's going to be, all right, well, just as long as x minus 1 is not equal to 0, this inequality will be true. Okay, and we can solve a not equation, just the same way we would solve an equation. And I'm going to say, all right, that's x is not equal to positive 1. So any number you think of besides 1, if you plug it into that inequality, it will come back true. That's what we're saying. Okay. And then absolute value of u is less than or equal to 0. Let's see if I have room to make that a little smaller. Absolute value of u is less than or equal to 0. Less than 0, that sounds wrong. All right, that sounds bad, right? Absolute value negative, no. Absolute value is positive or potentially 0. Okay, and that's where we're going to find something, right? Absolute value of u is never less than 0, but that equals can happen. So I would say never, except when u is equal to 0. And that's what we're going to do. Okay, we see the absolute value of 2x minus 9 is less than or equal to 0. We've already got it down to absolute value inequality number. Well, that absolute value can never be less than 0, but it could equal 0 if I was taking the absolute value of a number and having that come less than or equal to 0. Okay, that could only happen at that one spot, x equals 0, or number equals 0, pardon me. And so I'm going to take this thing over here, and I'm going to say, all right, this 2x minus 9, this has to equal 0 in order for this inequality to be true. If it's not, then I'm taking the absolute value of a number that's not 0, and it's going to come back positive, which is not less than or equal to 0. So I'm going to add 9 to both sides and divide by 2, and I get just one value, making the inequality true. And maybe if I remember when I go to record the lesson for absolute value graphs, I'll show you more about these special cases. Right, now the last examples I've got for you before I move on is going to be let f of x be the absolute value of 2x plus 1 and then subtract 10, and let g of x be 12 minus 1/3 of the absolute value of x minus 5. I'd ask you, where is f negative, or where is g of x less than or equal to 0? And I'm not sure how this is going to play out. We didn't get to these examples in my classes during the lecture, so I'm not worth these yet. All right, so f of x is less than 0. All right, well, I've got an expression for f of x that's 2x plus 1's absolute value minus 10. And that's going to be a negative number. Okay, well, we just learned how to solve this. We're going to isolate the absolute value, think about numbers, and then solve some inequalities after that. Okay, so we're going to add 10 to both sides. So that's less than positive 10. And we know that the absolute value of a number is less than 10, between negative 10 and 10. Okay, and okay, so that's where I would take 2x plus 1 and say it's between negative 10 and 10. Okay, I'm going to subtract 1 from both sides of both inequalities. And then we would get, by 2, I'd say x is between negative 11 halves and 9 halves. And if I needed to write that as an interval, I would say, all right, negative 11 halves, that's not what that's supposed to look like. All right, negative 11 halves and 9 halves, okay, as an interval. Okay, and for what x values is g of x less than or equal to 0? All right, well, g of x is 12 minus 1/3 of the absolute value of x minus 5. And that's going to be less than or equal to 0. So I think if I'm going to try to just get it down to absolute value inequality number, I'm going to get rid of that 12. Less than or equal to negative 12. And then I would need to get rid of that 1/3, and I might, oh, whoops. Oh, there's more examples below. I didn't see that. At this point, we're going to need to multiply both sides of this inequality by negative 3. Okay, so that will require me to switch the direction of the inequality. So that'll be negative 12 times negative 3 is positive 36. Okay, so that's good, right? Because remember, if we got absolute value inequality negative number, then we're going to have some sort of like really tricky thing we need to think about. Okay, so now if the absolute value of a number is greater than or equal to 36, okay, equal to 36 would be at 36 and negative 36. And where the absolute value would be greater would be out here, you know, where it's more positive and more negative, okay, larger numbers. Okay, so now I'm going to say x minus 5 is less than negative 36, or x minus 5 is greater than positive 36. Okay. From there, I'm going to add 5 to both sides of both inequalities. Okay, negative 36 plus 5 is going to be negative 31. And then over here, 36 plus 5 is going to be 41. Okay. If I wanted to write these in interval notation, I'd say, okay, it's less than negative 31, so it's negative infinity up to negative 31, union 41 to infinity. And if you don't want to use the union, you just want to use a comma, or just give me both of the intervals, I think that would be fine in algebra 2. Okay, I'm thinking, you know, I've got some more examples, and I might pull them up on screen right now. If you're feeling like you need more practice with this, you know, you should practice on this set. You should practice on my homework set for, you know, absolute value inequalities. But I think that what I've shown you is going to be enough. I think that I've done enough examples on video and talked through enough situations that you're going to be able to solve these on your own. You know, if you need more help with this, you should come talk to me about it. But otherwise, I'm going to say that's all, and thanks for